Hello?
Right, it's 29.
Yeah, I think we are live.
All right. How are you, Rosario?
All
Should we
good,
give
good.
a few minutes?
What
Should we
about you,
give
Boris?
a? Yeah, I'm doing great, thank you. I'm glad that we're here together to introduce that webinar. And I guess shall we give just one more minute for the people to join the webinar
Yeah, sure.
and actually start?
Yeah, that's good.
All right. I'll share the very few slides we've got to show. It's not about slides; it's about showing solutions and how they work live. So we'll keep that short. Okay. I'll just start when 31 goes live. I mean, today we will discuss basically how we can resolve voice over IP issues from the edge to the cloud, which is a topic which will interest a lot of people, I'm sure. Okay, it's 31 now, so let's go for it and start the presentation. Okay, so I mean, as you know, a lot of people know that networks are being very much distributed. I mean, work from home is an obvious challenge for most IT departments. I mean, we've got users distributed all over the place. We've got branches. We have new sorts of networks which use many different kinds of connectivity using SD WAN and other solutions or SaaS solutions in general. We see a lot of our customers actually facing intermittent and regional issues. When you have such a distributed environment, basically there are issues that might happen in one branch and not another that might impact users in using one operator or in a certain region. And that's becoming a very big challenge for IT department to be able to handle those. When we place that in the context of the transformation of company digital transformation, the massive use of SaaS, the massive use of cloud platforms, the migrations from MPLS to SD-WAN using public networks. Well, what we actually see at our customers is that many of those issues remain invisible to their IT tools and systems and monitoring systems. And that basically comes with a certain number of consequences. It's hard for IT departments to troubleshoot problems. It's very hard to isolate the fault origin. I mean, obviously, the number of infrastructure layers involved is far bigger than it was, and basically there are many possibilities when it comes to finding the source of the degradation. And in the end, the consequence is that the MTTR, the mean time to resolve issues, has boomed and has become massively high in certain cases when people can't restrict things. So in that context, what we want to show is how we can combine two solutions to fix those problems, basically of how services are delivered from the cloud to the edge locations using network traffic analysis powered by ProfitApp solution. IOTA is one, and basically being able to apply from the edge to the headquarters and the data centers, and Kadiska for the digital employee experience and the network paths between the edge and the cloud, which basically bring two sorts of benefits when it comes to reducing MTTR. We'll try to stay, as concrete as possible, and basically I'll set the scene for the demonstration we'll give just after that. Basically, we consider a very simple setup, which correspond to today's enterprise IT. We've got two remote sites, one remote site that you see on the bottom left, a headquarter with some data center activity in it. Both are connected through an SD-WAN and connected together, but also connected to other places like the cloud estate from that company. And we see that some of those users might use also a cloud protection or security service called the CASB, Cloud Access Security Broker, something like a Zscaler or Netscope, both for their on-site users and their home users. Okay, In that environment, we've deployed ProfitApp probes doing traffic analysis, both on the edge site here and on the main site. And we've deployed two sorts of Kadiska elements, a user experience element, which is basically sitting on the endpoint as an extension to the browser that you see on each user, and some network tracing stations, which are microservices hosted on the edge in the site and in the cloud. Okay, so that's the setup we have. And basically the case we want to troubleshoot today is quite simple. We've got VoIP quality issues from the edge site and from the work from home situation, but not from the headquarters. And we need to troubleshoot that. Okay. Rosario, are you ready to show what IOTA can do in that situation?
Yes. Sure. Let me share my screen. So first of all, let me introduce a bit what we do here in ProfitApp. Then I guess you can see my screen, right?
We do.
Okay, great. So ProfitApp is an European manufacturer of network visibility solutions. So our products are designed to allow the customer to access their traffic data in an optimized way and to feed it to their security and monitoring infrastructure. Today, we're talking about the IOTA. As already introduced by Boris, we are going to deploy our IOTA on one of the branches of our infrastructure. And the IOTA is a particularly good solution for this use case because it's a portable all-in-one capture and analysis probe. So as you can see here, this is our page. The device is quite a small factor, presents on one side capture interface. It comes in two ways. So a fail-safe copper 1G or SFP plus. That can operate inline or in span mode. We also have a physical button for like local control. And on the other side, we have of the device, we have a monitoring interface that can be used to control the device remotely and allow you to observe the state of your network from an overview, given the traffic analysis, and also to extract the pickup. We will see in a moment how to approach that. So in my next tab, we have the interface of the IOTA deployed at our branch side. As already introduced by Boris, in our use case, we're looking at some troubles with the calls of the VoIP traffic. We have already focused on the time window of the problem, so the report issue. And we can really have a very short overview of what's happening. So what client and server IP were involved in this communication. Our probe is placed, in this case, on the edge of the infrastructure. Given that we're looking at VoIP traffic, we can navigate the metadata extracted by the traffic analysis using the multiple dashboards. In our case, we can look at the VoIP, where we have an overview of all the calls registered at this edge. So we see we have 18 calls, we have information about the callee, the caller, and the duration, and so on. In our case, we also want to look at performances of these calls because we experienced some problems there. So we can move on a different dashboard, it's called details, where we can get an overview of all the calls. But if we scroll down, we can have an overview of the jitter and the packet lost. In particular, we see that in this specific time frame, we have quite high jitter and quite significant packet lost. So what we can do this in this dashboard, but for any dashboard, we can zoom in on a specific time frame like this one and focus on what's actually happening here. We see that we still have a few calls in parallel. We want to identify which specific call was impacted by this issue. Then we can look at the rest of the dashboard because all the information here of the dashboards are all correlated together. So we can look at this specific VoIP call by chance, which has this maximum jitter, and apply a filter simply pressing on one button. At this point, the whole view is focusing on this single call. We can see that this call is made of 3 actual traffic flows. We're talking about TCP/SIP, UDP/RTP, and UDP/RTCP. We can now decide how to look further in this traffic. So we could focus on one specific of these flows, adding an additional filter. So in this specific case, we can look at the traffic generated by this RTP flow. And here, I think we can leverage one of the most significant features of IOTA. So we can drill down to the traffic. So simply pressing on this button, we could be able to download the pickup, which will only contain this call. And this pickup could be processed with other tools, Wireshark or anything else. An alternative could be to navigate to a different dashboard to see other information related with this call and with this flow. So, by chance, we can go on the Explore dashboard, where we can have an L2, L7 overview of the traffic. So we can see which port I use, the source destination, the IP source, IP destination, and so on. So the power of it is that really allows you to start from an overview of the problem and then dig down to the specific issue, given the information you have, and extract ultimately the traffic. Ultimate things, we can navigate back to our home dashboard, and we can have a final view on the amount of traffic which is being used in this specific flow. And I think this can already really give you a feeling of what we can do with our IOTA. And this information can be useful for further investigation, by chance using Kadiska solution.
All right. I mean, that's great, Rosario. I understand, I mean, from what you've just said, that basically the call was degraded due to poor network conditions. And that's exactly where Kadiska can help. I mean, basically here you see we've got the Cloud Avaya target that we are basically monitoring from multiple places. And I mean, quite obviously, you see the two locations from where we've got a bit of packet loss, but latency is bigger than in Europe. Okay, so the darker, basically, the stronger is the latency. And why is that? I mean, we see that latency went up quite significantly at that time. So if we want to really understand why did latency move and where is the degradation happening, I mean, in the end, it's good to know about the fact that it's the network, but you've got to understand where. Is it just the ISP? Is it the SD WAN layer which underlays it? Is it happening on the cloud network? Is it happening on the internet? Is that something I can do something about? Can I change my SD WAN configuration to work on it? All the typical questions you have to wonder about. And you see that in Dallas, that's where we've got the problem. You see the big bump in latency. So if I want to understand, okay, what happened in Dallas and why did latency boom at that point, which you see pretty well. I mean, it was 49 milliseconds to reach the cloud PBX. It's now almost 200 milliseconds. And basically what I want to understand is, okay, what was the path I was following before when everything was right? And I'm just going to see exactly what path is taken. Don't be impressed. I mean, it's just the way a cloud network looks like. And you see, I mean, from San Jose, for example, where was my problem happening? It was happening actually in Dallas. So I'll just look at what is the path that Dallas is taking. Dallas is going through that network through Cogent and then going straight into the Amazon network because we are redirected to that cloud office, to that Avaya node in Amazon. Okay, that's when things go right. That's what's happening. When things go wrong, I'm gonna be able to understand whether it's a degradation happening from a network standpoint or if it's the redirection. So again, we focus on Dallas, and we see that the path is totally different. So basically, I'm going out through that network. I'm using the Zayo network, and then I go into that network. Which is green here, which is the Cogent network. And that takes me simply to another place in the network, in the cloud network used by Avaya. So basically it's still in Amazon, but going to a different destination. So what's happening is simply that Avaya basically redirected me to a different node, which is further away from my users and my site. And that's not a network degradation. That's something I should raise. I should solve by contacting Avaya and saying, okay, you're redirecting my Dallas users to the wrong place. And that's why we have a degradation. So that's the kind of thing Kadiska can help with. And the second thing we can help with, obviously, is showing exactly what is the experience when you reach a cloud service. So for example, when you have users connecting to, I don't know, Google Suite, Teams, HubSpot, basically you can flag right away whether your users stand further away from a certain cloud, whether the experience is bad and what makes the experience bad. Okay, and basically you see you know that our users connect to are about 100 milliseconds away from HubSpot, and that has an impact on their overall experience. And if you want to deep dive and understand the impact of basically latency to the cloud, either from remote users using, different ISPs, or people sitting on different sites using different gateways, you can see that at a glance and identify exactly how people connect and what is the impact on their cloud experience in general. Okay, that's about the time we had to show that demo. So I think we gave you a clear conclusion. We know that it was a DNS redirection issue from Avaya, and that's basically how powerful the combination of ProfitTap's Yota and Kadiska together is.
Yeah. No, if there is any question coming, maybe we have a few minutes for question and answers. Okay. So yeah, thanks for this presentation. It was really nice to see these combined solutions.
It was great. Thank you all for your time. I mean, obviously, it's quite easy for you to get back to us and reach out on LinkedIn or whichever platform is easy for you for questions. And I guess both Rosario and myself will be happy to reply.
Sure.
All right. Have a great day then.
Thank you. Bye-bye.
Cheers. Bye.